I would now like to provide a brief demo of the pediatric dosing tool, which is a real-time interactive software tool for individualized dosing of monoclonal antibodies in pediatric care. Before I move ahead, I would like to highlight that these tool-based predictions, while they are capable of supporting precision dosing, they are intended solely for research purposes and should not be used to guide any direct clinical decisions. When you open the tool, this is the homepage that you are greeted with. The homepage gives you some basic information regarding what you can do with this tool. At present, the tool has two primary use cases. One is population simulations, which can be used in cases where there is no preliminary information available regarding PK concentrations in pediatric patients via therapeutic drug monitoring. The second is individualized dosing. So, for in cases where there is some PK concentrations available through therapeutic drug monitoring, the tool can be used to individualize all dosing predictions to that individual patient. So to get started, the first step is to choose your drug. The tool allows you to choose from multiple antibodies which have been approved for use in pediatric patients. Today, for the first demo, which would be on population simulation, we would be working with mepolizumab. So I have some brief information regarding the patient that I would be wanting to simulate. So we want to, so Today for today's demo we would be working with mepolizumab. The second question asks, does your patient have previous concentration information? For that we would go ahead and answer no. To continue then, we can then give information regarding our patient. So for today, let's choose a male patient, and our pediatric patient is roughly 8 years of age with a patient weight of 8 years of age would be somewhere around 29 kgs. For dosing information, mepolizumab has been approved for a dose of 40 mg sub-Q every 4 weeks. So let's go directly with that dose. So you have 40, you can also add loading doses in situations where you have a separate loading dose and a maintenance dose. But in our current situation, it's only 40 mg all throughout. So we go directly to the maintenance dose and put zero in the loading dose option. So we add your 40 mg. It allows you to choose from different units. So you can also put mg per kg and it'll automatically calculate the dose based on the patient weight that is provided here for convenience. And moving ahead, then you go for dosing interval. So for us, we put 4 dosing intervals. Here it's been provided in weeks. And then you can also add number of maintenance doses administered. So roughly around this time we add 7. So what it does is it uses all of this information that has been provided then to simulate PK profiles. As you can see over here, it simulates the PK profile pretty quickly. And if you want, you can also view PK profiles, population simulations in log scale. It also not only provides concentration versus time data, but also provides you with summary statistics such as trough concentrations, which can be then used to make decisions regarding if that dosing regimen is able to reach therapeutic thresholds or not. So this is the first part of the app. For the second part of the app, then you can, so currently the second part of the app is only available for IV dosed antibodies. So for now, since mepolizumab is subcutaneously dosed, we would change the antibody for this exercise and go to atezolizumab. So in this case now, since we have previous concentration information available, we'll choose yes over here. Then it takes you to another page where you are directed to provide patient information. So over here, you can provide information such as male, patient age, some patient weight roughly. Then it takes you to the next section where you can provide any previous dosing information that is available to you. And once you have incorporated this information, you can go ahead and add previous concentration information. So whatever data set you have, if whatever units of time you want, and then whatever units of concentrations you want, you can add all that information. So for example, roughly you can say 105 1.5 as 105, and you can add that. that. And you can keep adding each time point on that basis. Since for this demo, I did not want to waste your time on waste your time during addition of each. I have already added the information here in another tab, as you can see. So we'll be estimating individualized parameters for a male patient who is 15 years of age, has 52 kg weight, and was given 780 or 15 mg per kg dose previously, with a dosing infusion time of 0.75 hours. And the dose is given every 3 weeks, and number of maintenance doses that have been administered are 7 over here. And as you can see over here, we have added all the information that is available to us with regards to the time and the concentration profiles. What we can do now is click on run, and it takes a couple of minutes to run the estimation aspects of things. The estimation aspect takes a little longer than the population simulation aspect would take. Yeah. So as you can see over here, the model was able to fit the data pretty well to the observed therapeutic drug monitoring time points. And it also gives you a rough overview of the estimation results, the percent RSCs, to give you an idea of how confident you can be in this model. And once you've done this and estimated individual parameters, you can then move to the same simulation section, and it works the same as the population simulation section now, where you can then go ahead and give your patient information again, and the model has already been individualized to the patient that you're treating. And you can try out different dosing regimens, and like before, you can see what the PK profile for that particular dosing regimen would look like. Now we've gone through all the main features of the application. You should be able to define patient characteristics, simulate pediatric patient PK, and also evaluate different dosing regimens. You can choose to perform individualized dosing optimization, or you can use population simulations. I hope this tutorial helps you to get started with this application. And thank you so much for watching.